Okay, let's start. Let me know in case you have any problem, also with hearing my voice and with the video. Welcome everyone to this webinar in which we will discuss about applying your NCAP open source Python code for 2026 score computation. I am your speaker, Danilo Romano, and I work as a senior software engineer at IVEX. And here to help me today as a moderator, we have Thijs van der Weken, our product manager that you already met. A very quick introduction about IVEX. So we were founded in 2018 as a KU Leuven University spin-out. Our headquarters is in Belgium, and the majority of our workforce is made up of automotive software engineers. Here on the slides, you can see a bit an overview of our contributions and partnerships. But recently, we worked with NCAP to supply software to them for the Euro NCAP 2026 scoring computation logic that we will showcase today in this webinar. So let me go briefly through the topics that we will cover today. So we will first discuss a little bit about the challenge that the Python library that we are releasing today is made up for. Then I will guide you through the Python library setup and installation, so to make everything ready. And then I will guide you through the structure of the library, so you can understand the whole context of the library. But I also want this to be an interactive session. So we will use the library together. I will do a demonstration and we will do some workflow together so I can show you how to use the library. And then later we will have Q&A. So during the presentation, feel free to use the Q&A section on your browser. And then Thijs van der Weken will collect this question and we will address them at the end of the webinar. So you are encouraged to share your thoughts and questions. And then in the end, I will do some conclusion to wrap up the word. So let's start by a question. Let's make this session interactive. So we would like to make you a question, but it will be quick, I promise. And the question is, how do you currently calculate Euro NCAP test score? And please, Thijs, you can take from now on.
Yes, so normally you should now be able to see a poll on your screen, and you have 4 options to choose from. So you have Euro NCAP Excel spreadsheets, some custom in-house tools that you may have, other commercial software that you use in order to compute the score, or any other solution. I see votes are still coming in, so I will give you just a few more seconds until I publish the result. Also, if I publish the result, you can still enter an option later. So let's publish. So we see that, yeah, the Euro NCAP Excel spreadsheets are very popular with 35 out of the 46 votes, so more than 70%. And then the second most popular option is to use some custom in-house tools that you have available in order to compute the scores. Okay, so I think we can proceed to the next question.
Yes, thank you, Thijs. And very nice. Thanks for participating and for contributing and also for the questions. I will comment it in a second because I also want to go you through the second and last question, I promise, which is, what is your biggest challenge in calculating Euro NCAP score results? Thijs, please.
Yes, so normally you should see again this poll question popping up with now 5 options where you can choose from. So what is your biggest difficulty? Is it data handling? Is it understanding how this scoring logic works exactly, the score calculation complexity? Is it keeping up with these regular protocol updates? Is it more about sharing or standardizing results across the teams? Or is it just finding the latest spreadsheets with the right formulas again in order to compute your scores? I see quite some people already voted, but many are still coming in. So again, I will wait just a bit more before discussing the results. I can already share that for each of the votes, each of the 5, we have more than 10 votes out of 40 now. So we can see that all of these challenges seem to be present in some way, to some extent at least. The most popular one being now understanding the score calculation. And so this is something where this open source Python code can greatly help. And also with the other challenges, possibly it can mitigate some of these challenges. So I will now give the word back to Danilo so that he can introduce you to this Python code.
Thank you, Thijs, and thanks a lot for answering. I think your answers are very interesting because they also address some of the pain points that we tried to address with our Python library. So let me give you a quick overview about how currently the your NCAP rating 2026 scoring computation works and how it supposedly will work from now on using the Python library. So I see that some of your points, for example, is understanding the score computation and keeping up with the protocol update. Well, on the left, you see how currently the score computation are made, which is spreadsheets used by your NCAP, as you guys pointed out in the first question. And then the logic for computing the score is embedded into the spreadsheet. This is not ideal in terms of different things. For example, it's hard to debug the code, it's hard to do unit testing, and it's hard to make code robust. But it's also hard, as you were pointing out in the second poll, to keep up with the protocol updates because changing the logic in the single cells can be tricky. So that's why you see the change on the right, which is our proposal with using this Python library. And basically you see that we chose the same format for visualizing the scores, which is spreadsheets. So Excel spreadsheet will still be the data format, but the logic to compute the score is now made up by a Python library, where it's easier to version, it's easier to debug, and it's easier even to explain the code, since your biggest pain point was understanding the score computation logic. So as we pointed out what this library is made for, let's discuss a little bit about installation and setup. So we will do these steps together, but in these slides you will see all the requirements for using this Python library. Let's focus on the first part of the list. So first you need to have Python installed on your computer. And in particular, you need to have, as pointed out in the prerequisites of the library, you need to have Python 3.10 onwards. For using Python on your computer, depending on the situation, please check with your IT team if you can do that. But to install Python, we will use Windows as target operating system for the webinar today, but it's possible to do exactly the same things even on macOS or Linux. But to install Python, we have a link here in the slides that you can click, and basically this page will be open. So this is the Python homepage, and we will install now together Python. So if you go in the download page here, then it's possible to download and install Python through the install manager, or it's possible to get the standalone installer for Python, in particular Python 3.14, which is the latest stable version that will be installed. So if you click here, an executable will be downloaded, and by executing it, Python will be installed on your computer. Let me show you the expected results after the installation takes place. So in order to verify this, let's open a command prompt. So just by typing cmd on the Finder here, let me know if you can see my terminal. But basically, after installing Python, basically you can just type Python in your terminal, press enter, and the Python console will be opened. Since we downloaded and installed Python 3.14, you will see at the beginning of the console 3.14 as Python version. Let me go back to the slides, because now we completed the first part. We installed Python. Now what we are releasing today is a Python library that is published on a Python package index called PyPy. So if we click on this link here, we will see that this is the homepage of the Python library that we are releasing today. Here you will find the library itself, some information about the latest version. For example, you see that it's pretty recent, the latest version that we released. But you will also see all the instructions to install and to use the Python library. So for example, you can see how to do it on Windows, how to use it, and additional information that you can find on this page at this link. So now we will do the last step to set up the environment for using this Python library. As often is the case with Python projects, it is recommended to use a virtual environment. A virtual environment is an isolated virtual environment that contains a Python executable and all the library and all the dependencies that we will install together. So let's do it together now. So reopening the terminal that I opened before, we can see that the Python that we are executing currently can be found by typing the command where, that on Windows gives you the path where the executable is. So if we type where Python, we can see that the Python that we are using is our system Python, the one that we installed through the link before. So for using virtual environment, we need to do two things: create a virtual environment and activate a virtual environment. So to create a virtual environment, we need to use a Python module. Using a Python module is as easy as typing Python-m that specify the module. And the module that we will use to create virtual environment, it's called venv. I'm just using directory here just to collect all our results. So with typing Python-m venv, we just need to provide one last argument, which is the name of the virtual environment that we want to create. So let me just put venv for simplicity. I'm pressing enter now. What is being now is executed is the creation of a new folder. If we show, we have in this folder the venv folder, which has just been created. And inside this folder, we have the Python executable and all the dependencies that we are going to install. And we can even see it here on the Explorer. We have the NCAP folder, the one that we will use today as working directory. And then we have venv folder, the one that we just created with the isolated Python environment. Now we need to activate the environment. So this can be done by using a script that is contained in the folder that we just created. So if we go inside venv, inside scripts folder, we have an activate.bat script. If I press enter now, we can see two things. First, that we have a string at the beginning of our terminal that says that the virtual environment is activated, but we can verify it with using again the where command. So if we do where Python, we can see now that the first one, the executable that is first called, is the one exactly from the venv folder that we created before. And this is the Python executable that have been isolated. Now we have everything to install our library. So let's see on PyPy what is the command that we need to run. You can see that it just pip install your NCAP rating 2026. Pip is another Python module that is used to handle library and package installation. So if we do pip install Euro NCAP rating 2026 and I'm pressing enter, then in our isolated environment now is being downloaded the library and also all the dependencies of our library. So that's why it's recommended to use a virtual environment, because even if you have another Python project that uses the same library that we are using, for example, Pandas 2.3.3, if you have another Python project that uses another version of Pandas, then it's better to have isolated environments so you avoid version conflicts. So now we just run our installation of the Python library. You can ignore the last part of the message because it's just about updating pip itself, not the library. So how to verify that the library is installed? We will type this command, but I will explain the structure of the library in a second. So the Python library that we released provides command line interface. So we just need to type Euro NCAP rating 2026. That's the name of our library. And just to verify that this installation was successful, let's just call the help argument, which is a common one for providing arguments and description of the library. So I'm just pressing enter now. we can see that the output of this command will just be information about the library. This is just saying us that this is the Euro NCAP rating calculator 2026. We have some options and we have two commands, crash avoidance and crash protection, that I will explain you in a second. So let's go back now to the slide. In the slide that we have here, there are summarized all the steps that we did together, in particular with the instruction for setting up the virtual environment on Windows and some additional information for Linux and macOS. Now we have our Python library installed. Let's go to diving into the library structure. So what you see in this slide is a description of the command line interface that this Python library installed on your computer when installing the library, as we did together. So you can see that a full command, is made up of three things. On the leftmost part, we have the name of the library, which is Euro NCAP rating 2026. And then, as you saw in the terminal output, we have different commands. One command is crash avoidance, the other one is crash protection. The help command is just to provide the informative content that I show you before. So let's analyze one particular command, in particular crash avoidance. Each of these commands has a similar structure that also define the workflow that we will do together in a second in the live demonstration, the usage of this Python library. So the first part of the command is Euro NCAP rating 2026. The second part of the command can be crash avoidance. And then we will have three options: generate template, pre-process, and compute score. Let's just go into the detail of what this command does. So if we take the first path, Euro NCAP rating 2026 crash avoidance generate template, running this command will generate in your working directory an XLSX file that contains all the information for the test of the crash avoidance protocol group that this Python library supports. You can see that the file extension is XLSX because, as I said before, we decided to stick with the Excel spreadsheet as a way to represent test run, because it's a very powerful way to describe tabular information as the one that we will see together in a second. Let's go now to the second command. The second command is pre-process. So in crash avoidance workflow that we will see together in a second, we will have the necessity of selecting some test points. From the matrices, some test point needs to be generated, so to have the full list of verification tests that needs to be executed. And the pre-process command is doing exactly this. We just need to describe the last point, which is compute score. So after the first two, compute score is actually the core scoring computation logic. This command computes score and generates a new XLSX file with all the scores computed, which is the final goal of our workflow and the workflow that this library supports. For crash protection, we decided to keep the same interface. So if we go to the red path here, center of the slide, we can see that we have the same commands: generate template, pre-process, and compute score. The meaning, the effect of executing this command is exactly the same. Generate templates, generate an Excel file, pre-process, select test points, and compute score and generates a new Excel file with a report. Now that I show you the structure of the library, we can discuss about the workflow. So the three steps that I showed you before, generate template, pre-process, and compute score, are three commands that this library supports. But the workflow is a little bit bigger because it also involves input by the user. So now together I will show you the full workflow that goes from generating the template to having the report, also considering the input required by the user. So let's start with the crash avoidance command, just for example, but we will do the same for crash protection. And let's start with the first command. So we will have generate templates and we will have a template file as output. Let's do it together. So by opening again the command prompt that we used before, we can run the generate template command. So your NCAP rating 2026 is the first part of the command. The second part, as pointed out here, is crash avoidance, because this is the command that we decided to use for this demonstration now. Then the last part is the command itself, which is generate template. I just type everything and then I'm pressing enter now. You can see that we just have a console output that tells us that the template was generated at this path, and some additional information about the version of the library that was used for this command and for any other command that the library uses. So if we go now to the folder that we use, that we consider our working directory for today, we can see that we have now, beside the VM folder where our isolated Python environment is, we also have CA template file. Let's open it together. CA stands for crash avoidance. So as probably you guys are already familiar with, then there are different tabs in the crash avoidance template. Some tabs are there for the user to provide some input. For example, the prediction method that was used for CCRS for standard range. There are some tabs that are used for summary of the scoring and on the score logic. So we have test score that gives us the score for stage element and stage of element, for example, frontal collision, car, and powered two-wheelers. But then we can have more detailed information, for example, at category level, longitudinal turning crossing, or at scenario level, for example, at single test level with the distinction between standard, extended, and robustness score. Beside these general tabs, we also have detailed tabs for given stage element and stage sub-element. So for example, FC current PTW stands for frontal collision, current powered two-wheelers. And for each of these, we will have a prediction tabs that contains the metrics published in your NCAP protocol. And we also have the robustness layer tab. In the robustness layer tab, we have a column for each test, and the user can specify if a robustness layer is applicable or not. This is the content of the template. Here in this slide, I'm just providing a summary of the information that I just showed. So the list of supported tests goes from frontal collision protocol, in particular current PTW, pedestrian, and cyclist. We also have lane departure collision and low speed collision contained in the same template, the crash avoidance template that we just generated. Now we have the description of the content of the generate template command. But now this is the first moment in which the user plays a role in the workflow, because to the template, it is required by the user to provide prediction. And I will show you in a second how to do it. If we open again our template file and we take as reference the frontal collision current PTW prediction tab, we can see that by clicking on each cell, it is possible to provide a prediction. A prediction is a colored cell that specifies the expected performance for a specific test run. A test run is one cell in this matrix because it's telling us that the test run for which we expect a yellow performance is the one where VUT is driving at 20 kilometers per hour. Vehicle under test, is driving at 20 kilometers per hour. GVT is stopped because it's a stationary test. AB is the function selected, and the impact location is 75%. So this is the way in which the user provides prediction. We can do it by providing different colors, yellow, orange for standard cell, for example. We can have brown, and we can have a yellow here, for example. And we can also specify which robustness layers applies. Let's use an example, CCRS. So for example, we can say that driver input pre-crash, it's not an applicable robustness layer, neither appearance nor infrastructure, for example, clutter. And as you can see, I've done it by clicking again on the cell and specifying the desired value between yes and no. So now that the user provided the input, I can save the current template by clicking on this icon here. So now we have a saved template in which prediction have been provided. So we can go to the second step, The second step, the third step of our workflow, sorry, is to run the preprocess template. The preprocess command takes as input one file, which is the template where we saved our prediction, and produce an intermediate result, which is preprocess template. So let's run this together now on the template that we just saved. So in order to do this, we need to construct our command. So starting again from Euro NCAP rating 2026 crash avoidance. This part didn't change. And then the command is preprocess, for which we need to provide the input -e CA template. I'm pressing enter, and you can see that now the logic of test point selection starts kicking in. And then from the taking into account our prediction and all the prediction provided in the template, test points are now generated. We can see the usual output here, but we can see that in our folder we have CA preprocess template. I can open this file and we can check it together. So we can see that some tabs did not change. For example, input parameters, test score, scenario score. It's not yet the time for having the score computed, but these will be the tabs in which the score will be provided to the user at the end in the report. But let's open the current PTW prediction. So as you can see here, we have first our prediction taken into account, and second, we will have 1x for each of the test points that have been randomly selected, by also taking into account our robustness. So in the preprocess template, the file that we are now using, there is an additional tab, which is the verification test tab. So here, given the test point selection made by the preprocess tab, so this is the first moment in which we have this tab here, we will have one row for each of the x that are selected previously in the matrix here. So for example, we expect one green, one orange, and one brown point being selected. And as we can see in the CCRS test, we can see that we have one green, one orange, and one brown point as expected. Just for completeness, this is done for all the protocols that I shared with you before. So for example, we have it for frontal collision, pedestrian and cyclist. We have it for lane departure collision. This is a single vehicle part. Or, for example, we have it for low-speed collision. This is, for example, the car and PTW subsection of the low-speed collision protocol. And they are all taken into account together. So now we do have the pre-process template. Now it's the second moment in which the user needs to play a role, which is to add the test value. Why? Because after the pre-process step, we now have the list of all the verification tests that needs to be executed. After executing tests, we will have one value that describes the performance of our vehicle in a given test. For example, can be a flag signaling whether a collision occurred or not, or how much is the speed reduction. Based on each test, this value may differ. So now in the pre-process template, we act as a user and we provide some input. So for example, let's take the CCRS test again. We now go to the verification test tab and we provide input by using the value column here. So for example, we can provide some random values now just for the test. And now we need to save the pre-process template where we provided the value. So I'm clicking again the Save button here. We will now close the preprocess template, and now we can go with the next command. The next command is also the final one, and is compute score that takes as input the preprocess template with our test value and will generate the final report. So let's run this command together. So the command again is Euro NCAP rating 2026 crash avoidance. And what we need to run is compute score -e CA preprocess template. You can wonder, how do I know that the input file needs to be provided with the -e? So you can get this information by running the help command. So now, just for demonstration purpose, I run Euro NCAP rating 2026 crash avoidance compute score help. And we can see that it's possible to specify the input file with -e and the path to the output directory where the report needs to be saved. For now is our working directory, but it can be specified as a separated folder. So I'm just pressing up now to have, again, all the command. So again, Euro NCAP rating 2026 crash avoidance compute score. We can now provide our file as input, which is CA preprocess template. I'm pressing enter. Now the score computation logic is working to compute the final score for the test and test runs that we took into account currently. And then at the end, we will have a new file, the report file, in which all the scores will be computed. So as we read here, we can see that we have our final report available at this path. Basically, we have CA, that stands for crash avoidance. Then we have the information about the date time, 1st of December. And then we have the report string. So let's open the Explorer again. And then we see that close to the template and the preprocess template, we now also have the report file. Let's open the report file together. In the report file, some things did not change again, for example, input parameters or prediction, but now we have our numbers in the score column for the scenario score, as you can see here in our CCRS. For the category score, as you can see, the reflection of our CCRS performance on the longitudinal category and on the test score. And this is the contribution of our CCRS scenario on current PTW stage sub-element for frontal collision. So this is the final output of our workflow. We did these three commands together, and we generated the final report by providing our input in the middle. We did this example with crash avoidance in mind, but we can do exactly the same for crash protection, for which I will just go quickly in the presentation. But let's do also the crash protection workflow, because I want to show you the completeness of the Python library that we are discussing today. So let's now do the crash protection workflow. So the first part of the command will still be the same, Euro NCAP rating 2026. Now we need to type another command, which is crash protection, and we can start with generating template. I'm just pressing enter, and we immediately have our template called CP template. You see that this is the file. When sorting by updates, you can see that this is the latest file that has been generated. Let's open the CP template. In the CP template, in a structure that is very similar to the previous one, we can see that we have input tabs, we have single tabs for each test and load cases, and we have the summary one. So let me close it now, and let me go forward. So in the generate template again, I have our crash protection here. Okay. So we can provide our input. That's the first part in which the user kicks in. So let's take as input, for example, frontal offset, and we can provide our prediction. The prediction are provided for crash protection only for one specific test, which is the VRU, for which we have a matrix that is very similar to the crash avoidance matrix. So now we need to add our prediction, and we add our prediction by specifying a color in this cell. So let me create a random prediction for now just by copy pasting this color in different cells. So let's, for example, pick yellow for this section here, and by copy pasting, we create a uniform region of yellow. That's just an example. And we can do the same, for example, for orange. I'm copy pasting and I am generating a uniform region of orange prediction. And we can do the same in the lower part here. So we can specify orange and copy pasting this. And then we can specify yellow, copy, and paste this cell. So now we have a full prediction provided for VRU part, which is vulnerable road user, as you can see here, in which we see that we take into account cyclist older than child. So I can save the template now, I can close it, and I can run the preprocess. Euro NCAP rating 2026 is still the first part. Second part is still crash protection. Now we need to run preprocess -e, and CP template is now our input. Just pressing enter, And now the logic that is called is the VRU test point selection logic. So only for that test in crash protection, the test points are selected. Let's open the pre-processed template that have been just generated now. And now in the pre-processed template, close to all the other tabs, we also have first the test point selection visualized with the X, exactly like in crash avoidance part. But we also have two new tabs that describe the head impact list of selected test points. So again, one row for each X selected before. And then we have the same for pelvis and leg impact. So now in the pre-processed template, we have verification test tab in which we have one row for each test that needs to be executed, which is also the first, the beginning of, for example, side and far side tests, in which we have one row for one test that takes into account a given criteria. Now that we have the pre-processed template, exactly like we did before, we can execute the test and specify the value. Let's put some random values here as we did before. And we can run our compute score logic, but we can even do it, for example, for frontal offset case, in which we are going to specify FZ tension criteria for the test that we executed. Let's put 2.1, so it's a value between HPL and LPL. So after providing the values, we can save. And now we can run the last command also for the crash protection part. So Euro NCAP rating 2026 crash protection is our constant part. And now we can run compute score -e CP preprocess template as we expected. I just press tab to have the automatic completion of the command. But this is the input that we need to provide. Now I can press enter. You can see that we have slightly different logs, but still what it's doing now is that it is computing the score by taking into account the value that we provided after the verification test have been executed. And we can see that we have now our final report here that we can inspect together. So by opening this file, we can see that now in the crash protection section of test score, we have the score for all these tests. We have the dummy score provided. So for each dummy, what is the performance? And also for each body region, what is the performance? These scores are computed taking into account our prediction and our test values provided in the two steps that we did before. So this completes the description of the two workflows that I wanted to show you today. So crash avoidance with the 3 steps: generate template, preprocess, and compute score. Crash protection with the 3 steps: generate template, preprocess, and compute score. So before going to the conclusion, I hope that you will have questions, and please, Stace, help me with that.
Yes. So I see we have a few questions in the Q&A, which we can ask. So first, what is the plan for the safe driving and the post-crash assessment within the tool? Is it going to be supported as well?
Yes. Thanks for the question. Thanks, Dave, and thanks for the question.
Yes.
So yes, we plan to add also these two protocols. We are aligning with Euro NCAP to release them, but in the coming weeks, we will also have further release. You can just be updated by inspecting the PyPy link that I showed you before, where you will have a new version, which we will include this protocol in the future.
Yeah. Okay, thank you. Then we also have a related question. So each time there's a new release, will there be a detailed summary? Will there be some documentation explaining the score calculation logic change at every protocol update?
Yes, thanks for the question. Thanks, Dace. Absolutely, in the README, which is the file that is visualized in the PyPy homepage link, we will also provide any update about any change in the score computation logic, so you will be updated by that. And also, by installing the library with dash upgrade, if you do it sometimes, quite often, then you are automatically updated, because with dash upgrade, you automatically download the latest version of the library.
Okay, that's clear. Then another question, a graphical user interface, is that something which is planned, or will the tool remain command line only?
Okay, thanks, Dace. Thanks a lot for the question. So currently, this Python library is only meant to be executed as a command line tool with the purpose of showcasing score computation logic as we are releasing today. For the graphical interface, that's part of our other products at IREX, but that are not part of the discussion today.
Okay. Yeah, just a minor thing. Danilo, could you please unmute in the Microsoft Teams, just so that people can also hear your answers there?
Yeah, sorry, I was trying to avoid the double.
Yeah, I see. Sorry. No worries. Then another question. People are wondering if the MME test results, if they have to be entered manually in the spreadsheet, or if there is a way, such as people are currently doing, to automatically populate basically the input spreadsheet and then use it in the tool.
Okay. Thanks, Dace. Thanks a lot for the question. Very interesting. So the purpose of the library is to be used, as I showed today, so with manually providing test values. Then we are working on other products for having an automated integration, but that's not part of the library of today. The library has the scope that I just presented, but for the integration and for the GUI, please ask us in separated way.
Okay, thank you. Then another question is about the logic for the random selection of verification tests.
Okay.
So yeah, is this logic exactly what your NCAP will also use? What kind of logic is this?
We are applying, thanks Dace, and thanks for the question. So we are applying the same randomness selection of test point. So this library does not guarantee that exactly the same test point will be selected, but the logic is inspired to the one that your NCAP uses to select test points.
Okay. Yeah, then I see also some questions related to if we share the slide deck in the recording. So we will share this slide deck to all attendees after the meeting. And also the recording will be shared. So no worries on this regard. Then if you have time, maybe I will tackle one more question, but we won't be able to tackle all the questions in the Q&A. We will answer some via email after this meeting. So just one more maybe. Does the template need to be filled for all load cases in order for it to work? Or can I get score calculations on a few load cases only?
Thanks, Dace. Thanks for the question. It's an interesting one. So as I show you in the demonstration, it is possible to provide test value only for one test run or even for one test. I would say that in order to have a representative scoring, you would need to provide input values for at least a test. So considering all the test run of a given test. For example, car-to-car rear stationary that we did before, we had 3 standard test point and 2 extended test point. If you have the values for all those 5s, then the CCRS scoring that you have in the summary tabs will be more representative.
Okay, thank you. It's clear. And finally, I also want to mention that unfortunately, our product manager, Thijs de Vos, was not able to join today, but that you can also reach out to him via email later, as he was originally the planned presenter, but could not make it today. Yes, so that's all, I think.
Okay, nice. I can go to my final slide then. Thanks, Dace. And thanks a lot for all the questions. And by the way, we will collect also the question that we didn't manage to answer, and we'll get back to you by email, of course, because we want all your doubts and remarks to be addressed. So in the meeting that we had today and in this webinar, we released and published this Python library. And the purpose of the Python library is to help OEM and suppliers in understanding exactly how points are computed, and also to provide a reference implementation on how Euro NCAP expects computation. This is also to address the transparency part that you mentioned in the first poll. So having such a Python library goes into the direction of providing an enhanced transparency, explainability, and traceability to score computation. It will be easier to version it, it will be easier to debug it, and it will be easier to iterate on the logic itself to make it cleaner and to make it simpler and more transparent. So what we encourage you is to try it. So to download the PyPy using the PyPy link here, to download the library and to use it on your computer, and provides us any feedbacks, any remarks, or any question. So please talk to us, send us here. Here you can find our contacts from Gwendal, Mario, and Tace, the product manager that Tace just mentioned. So you have our emails. Please let us know what do you think about the library, if you have any problems, or if you have any specific requests. Thanks a lot.